treat it as a national security issue. I don't want to mince my words. The most important shift I would like to see is political will. How the pollution is happening is clear. We need the politicians to work on that so that we don't have to breathe poison.
2025 has been a brutal and bleak year for climate actions. Emissions of greenhouse gases rose, disinformation went mainstream, major climate negotiations, especially the COP30, under-delivered, and globally we are losing ground. But instead of dwelling on the despair, we are asking if 2026 is to be the year we finally course correct, and what would a successful year actually look like? So in this 2026 look ahead, I'm speaking with an insider, Dr. Roxy Mathew Koll. He's a lead author for the UN's IPCC, which is the world's most important climate change science organization, which has government representatives also, and one of India's topmost climate scientists. His focus is the rapidly warming Indian Ocean, and that's something which matters to every family in India. Thanks very much for joining us, Roxy, and for making time for this conversation. One thing I'd like to flag right at the start is how you actually communicate climate science in a very simple manner. Like you recently wrote about I think
Yeah.
The Ditwa cyclone, where you said that the infrastructure of the last century cannot meet the extremes of this century. But from your perspective as an IPCC scientist, what is the single most crucial shift that you think needs to happen at a global policy level for 2026?
Yeah, Chetan, good morning. And this is an excellent point of discussion that we are having. I'm happy that we are thinking and discussing about what we should do, not just, what all is happening, what kind of science is behind them, but also what actions need to be taken. And this is exactly what I would like to see as a climate scientist too. And the most important shift that I would like to see is political will. And that encompasses everything, political will, because we see that for the last several decades, the science has been crystal clear in terms of what is happening with the climate, how it is happening, and who is causing that. What are the sources? What are the numbers? You talked about COP, the Conference of Parties through the UN, and we have reached COP30, which means for 30 years, globally, nations have been coming together to take decision on the science that we have already churned out through several IPCC reports, several publications, and so on. So what is lacking, what is not keeping pace with that scientific reality, with that climate crisis that we see, or in the map that we are showing here, is that the political will is not keeping pace with that in terms of either with mitigation or with adaptation. And it's not just in one country across the globe. It's a reality. Except for a few nations, uh, there is, I would say, there is more talk than walking the talk. There are more meetings and I would say parties rather than binding decisions. So what we need for 2026 and from the next year onwards is a major transformative shift in terms of political will. For India and for other countries, we should treat it as a national security issue. It should not be just a uh, climate issue or environmental issue, but a national security issue closely linked with public safety and health. And if you just look at this map across India, we are seeing extreme events from Himalayas to the south. We know that on all sides of India, we have either the warm waters of Indian Ocean or the Himalayas. Both are changing at a rapid pace. And we see one extreme after another affecting the billion population. So for 1.4 billion population, that is what India is now. And for entire South Asia, which has the same kind of density and similar kind of extremes, it is a national emergency. On war footing, we need to work on that political will in terms of climate action, climate mitigation, and not only climate mitigation, but also adaptation. We see that many times India is vocal about mitigation in terms of renewable resources, though we are not keeping on pace with that. But we seldom talk about adaptation because it's not straightforward. It's not as glamorous as mitigation, and it needs to be worked out locally. So that's my wish list. My only wish list is political will, because the science is clear in terms of what is happening, how it is happening, the sources, how we can tackle it to some extent. And the political will is missing at local level, at state level, at national level, at global level.
So, putting that so lucidly, you shared with me the data on the multiple threats facing India, like we're seeing in this map, from ocean warming to extreme heat and more intense cyclones. Now, at an individual level, I think for a lot of people, this can feel so overwhelming and
Yeah.
so distant that people understandably ask usually, how does a 2-degree warming decades from now affect me today? And what can I even do about it if the Indian Ocean is warming or the currents are changing in the Atlantic? Can you break down the most urgent individual and family level threats we are facing right now? And we can use this map as a reference. If you can start picking the issues off and talking us through them. Let's start
Yeah,
with heat, for
definitely,
instance.
Chetan. And when we say 2 degrees Celsius and it's in a far distant future and all, I would say we are already on the curve, and we are at around roughly between 1.4 and 1.5 degrees Celsius already. And we thought even that is like a distant future. A few years or a couple of decades ago, when we were talking about 1.5 degrees Celsius. But that shift from 1 degree Celsius to 1.5 degrees Celsius happened in less than 2 decades. In roughly one and a half decades, that shift from 1 to 1.5 degrees Celsius already happened. And here, even zero point 0.1 degrees Celsius is quite important because it generally means the average.
Can I
Yeah,
pause you? Can I pause you right there? 1 degree, 0.1 degree doesn't seem like
very
very
much. Yeah,
much. And even after 30 years of climate talks, this is still an issue which
yeah.
keeps coming up. So if you can simply explain what is the big problem with such a small number?
Exactly. So what we measure in terms of the global warming levels, yeah, is actually the global mean surface temperature. It's a measure the change in the global mean surface temperature. So across the globe, different kind of monitoring systems are checking the surface temperature, and it's the mean surface air temperature just above land and ocean. So if you average it, the average temperature of the global surface air temperature is around between 15 and 16 degrees Celsius. So let us take it as 15 degrees Celsius to, just to round so that it's easy on the audience. And so if it was 15 degrees Celsius before pre-industrial times, that is around 1850s, 1870s. And since then, we have been pumping carbon dioxide because of fossil fuel emissions, because we had suddenly starting using cars, industries, which burn coal in the solid form, which is the most carbon dioxide emitting, and then, in liquid form, like petrol, diesel, and all, which is the next pollutant, and then gas form. So all these fossil fuels emit carbon dioxide and has been trapping or increasing the energy trapped in the atmosphere, which has been increasing that surface temperature levels. So we have reached around 16.2, 16.5 degrees Celsius. That is a 1.5 degrees Celsius change in the global average temperature. But when we say average, it means that in some areas it is warming more. It could be 2 degrees Celsius or more, or 3 degrees Celsius compared to the pre-industrial levels. And also, we need to think that this is a annual average, which means that some seasons, especially the hot seasons, the temperature uh, that we feel at home, at your home, at or outside on your farm, it could be around maybe 5 degrees Celsius or 6 or 7 degrees Celsius than the usual on some days, and that we feel as heat waves, during the heat wave season. For India, the heat wave season is generally during March, April, May, as creeping on to June, depending on where we are, if it is north, and how fast the monsoon is picking up in June, and so on. And if we look at this mark across India, one thing that is most common is the increase in heat. It can be whether it's South India, Northwest India, North India, Northeast, or Southeast India, heat is increasing across. It is non-uniform, but still we see that some areas, the increase in heat is quite different from other areas. For example, Northwest India, it is more dry heat increase. But South India or Northeast India, it's more humid heat increase. And this has different implications on health. And this sometimes compound also. We cannot see heat as a single, though you want me to discuss on heat, many times it compounds or overlaps with other kind of extremes and makes it difficult. The impact on humans at our homes or at our workplaces outdoors will be overlapping effect because of multiple factors. So sometimes it could be because there's more humidity. I'll give you example of how it happened for Mumbai a couple of years ago. I think it was in 2023 April. It was not very hot. It was just 36 degrees Celsius. There was a big rally. Five lakh people participated in that rally, and it was open space, open grounds. I think it was in April, and temperatures were 36 degrees Celsius. And Indians are generally tolerant for high temperatures as long as they are not exposed for quite a long time. But by the end of the rally, it was political ceremony, and around 14 or 15 people died in that ceremony, just because of because they were exposed to this climatic factors. And this was because not just because of heat, but also humidity also played a fact. The humidity was around 60% or more. So overlapping heat and humidity, human thermoregulation breaks down. So what happens is when there is more heat, the way the body regulates the heat is by sweating. So that sweat happens, and once that sweat happens, that sweat evaporates, that cools down the body. So for sweating to happen, our the blood pressure system or regulation also changes. The body pumps more blood towards the skin, and when it sweats, so that the skin cools down. But this means that the blood is flowing more towards the skin, your outer layer of the body. And when the body also cannot cool down because there is more humidity, because the evaporation is not happening, the entire blood pressure, heating, thermoregulation, everything breaks down on your body, and multiple organ failure happens. People die, and that's what happened in a place close to Mumbai, Navi Mumbai, in April. So these kind of events are happening very often. I think last few years we saw several heat wave related deaths in Bihar and so on, because they were in the farms waiting for the monsoon to happen. But some years, some of the earlier years, not this year, but previous years, the monsoon came late and the heat extended into June. And this resulted in more deaths happening because people were outside waiting for the monsoon that was supposed to happen on time, which didn't happen. So you see, multiple factors cascade or overlap into extreme heat
So,
bands.
so looking at this map, and if I look at it in detail, most of it is what is a threat that you're talking about, heat. And it's about heat stress, warmer nights, warmer days, the compound effects of hot and
Yeah,
dry extremes. And also, I think in the IGP, Indo-Gangetic Plains, it says that there's a decline in mean JJAS rainfall, which I presume implies a fall in the
yeah,
monsoon
June, July,
rainfall.
August, September. Yeah.
So it's June, July, August, September. So heat is going to be the single biggest threat for India, because there are others that I guess you'll talk about on glaciers and rising sea levels and intense cyclones.
Yeah, definitely. I just wanted to add one more point on the heat, because we talked about warm nights, because this is another reality that we are creeping into because of urbanization. So just like more carbon dioxide is creating a blanket and trapping that heat, our urban concrete jungle is also kind of creating a blanket and trapping more and more heat. So that's totally a local construct. So if you're talking about India, the urban heat that we are feeling here, whether you are in Delhi or in Pune here, or somebody in Mumbai or in Kolkata that they are experiencing, is totally a local construct. And this results in warm nights, warm or hot nights, where humans are not getting a respite in terms of pulling their bodies down during the heat wave season. So usually the solar insolation happens during the daytime as short wave, and this is supposed to bounce back as long wave during the night, more because there is no shortwave incoming during the night, and the land and the area around us is supposed to cool during the night. But the urban framework that we have, because we are not conserving open spaces, we are not conserving the trees and the jungles around us, so the heat is being trapped by the urban setup. So in fact, if you look at satellite images during May, June, especially at the area where you are staying, Delhi, we would see that the land surface temperatures at night, if you compare between Delhi and the semi urban or the natural open spaces next to Delhi, we see up to 15 degrees Celsius difference in nighttime temperatures. These are satellite derived evidence data that we have seen. And you can imagine how much you can imagine that is totally a local construct. So you cannot blame it on carbon dioxide emissions, historical carbon dioxide emissions from US, Europe, Russia, Japan, and all. That is totally India's own making, the concrete, urban related heat, warmer nights that we are experiencing in India, in particularly in Delhi and other places, cities like that. So now let us move on to other extremes that we talked about, the monsoon related extremes, the cyclone, the more water related extremes. This is where we can connect well with the ocean warming. Even the heat waves that we feel, sometimes they are related to the ocean warming. So earlier we talked about the global mean surface temperatures. So that doesn't actually encompass the entire global warming picture. And I'll make it clear why. Because more than 93% of the heat from global warming is absorbed by the oceans. So the land, atmosphere, ice, all these other components other than ocean together absorbs only less than 7% of the heat from global warming. And it's an average of that surface air temperatures that we talk about when we talk about 1.5 degrees Celsius, 2 degrees Celsius and all. The heat that is being absorbed by that 93% of the heat that's being absorbed by the oceans are not accounted in that global mean surface temperature change, global warming levels. Yeah. And this is absorbed by the ocean. And most of the audience won't know how big the ocean is. We know that oceans cover 73% of the globe's surface and all. But if you talk about the average depth of ocean is around 4 kilometer. Ocean is 4 kilometer deep. Compared to, we know it's all water, salty water. And this ocean, because it's water, the heat capacity, the storage capacity to store heat is much more than air or water. So that's, yeah.
Land.
Chetan?
Much more than land.
Yeah, sorry. So the storage
Yeah.
capacity of water or the ocean is much more, several times more than air or land. So, which is why we say ocean has a long-term memory. And this heat absorbed by the ocean will stay there for centuries to come. While atmosphere, it can forget the heat, it can go from heat to cold pretty fast and respond to other kind of changes. But the ocean, that heat is absorbed in that 4 kilometer average depth across that 73% surface, right? So this kind of a slow process keeps on absorbing that heat. This comes out occasionally as, through different events like El Nino. El Nino happens as a natural oscillation in the Pacific. Sometimes the Pacific, some years, like once in 5 or 7 years, this is not a periodic oscillation. The Central and East Pacific suddenly warms up. Some fights in the same periodicity, it cools down also. That's called, so when it's in a warm phase, it's called a El Nino. When it's a cool phase, it's called a La Nina. And we are seeing these kind of El Ninos are becoming much more aggressive or stronger. So earlier, when we used to have a El Nino, the Pacific, the sea surface temperature anomalies in the Pacific used to be just maybe around 1 degree Celsius on an average, but now it's around 2 degrees Celsius. And we see that La Ninas are not as cooler as earlier. So these kind of events are warm episodes are happening. Similarly, the Indian Ocean is warming throughout the year. And we don't have that kind of oscillations like the El Nino, La Nina in the Indian Ocean, other than the Indian Ocean dipole, which happens once in a blue moon and doesn't make, you know, huge differences uh, here the warming is a consistent factor happening in the Indian Ocean, and we have heat waves in the ocean also. And heat waves in the ocean, we call it marine heat waves. And this is a new term which was coined in the last 1.5 decades. The first time it was coined was around 2011. But because the heat has been accumulating over time, now we are seeing more of these kind of events. So we are recognizing and identifying these kind of events. So what happens is when we have more heat in the ocean, and this heat is accumulated over the surface of the ocean more, it connects with the atmosphere, the air above it, and changes the circulation. And we know that the monsoon that we receive, especially the summer monsoon during June, July, August, September, over across India, is that it originates from the Indian Ocean, especially the South Indian Ocean, crosses the equator, and then hits Kerala, Western Ghats, crosses central India, and part of that goes into the Bay of Bengal, recurves back onto east and northeast and North India and so on, reaching up to Delhi and beyond. So this monsoon that we receive, about 80% of India's annual rainfall, all our agriculture is largely dependent on this rainfall. It's all maybe 50% or more, around 50-55% of the agriculture in India is totally rain-fed agriculture. It needs this monsoon rains, otherwise it fails. Because irrigation, though India has made a huge progress in irrigation, still there are a lot of farms totally dependent on rain-fed agriculture. So these monsoon winds are regulated by the changes in the ocean and over the land, because the heat contrast, not just at the land, but also between land and ocean also matters. Because during the summer season, that is May, June, July, August, September, land is generally warmer than the ocean. So the monsoon winds move towards the land. But now, because the Indian Ocean is warming at a fast pace, this gradient has kind of weakened. So we see that the monsoon winds are not as strong as earlier. It is not bringing that rains inland. So that is resulting in failure in agriculture, especially the Indo-Gangetic Plain, where agriculture is the mainstay. We see migration happening. So there has been publications showing that domestic migration is happening within India. People from, for example, from the Indo-Gangetic Plain, from UP, Bihar, and all, are migrating to the mega cities like Mumbai and all. And there they are facing a totally, this is because the agriculture and the rains have failed them. There in Mumbai and other mega cities, they are facing a totally different set of climate change extremes. That's where we reach cyclones and sea level rise and all. Because because the population that is migrating, they are the most vulnerable. They don't have a roof of their own. They may live in makeshift houses. So if you see some aerial photographs of Mumbai along the coast, you would see a lot of blue polythene sheets along the coast, and they occupy this kind of low-lying areas and without a proper roofing. So what happens is that, yeah,
In fact, in fact, that's quite interesting because the role of climate change in migration does not really get spoken
not at
about
all.
that much, the way you're
Yeah.
describing it. But it seems to be the most underlying feature that, The returns on agriculture are
Exactly.
declining, and migration is driving that. But they're going into these urban clusters, which either have cyclone and rising sea level, or if it's inland, like in a place like Delhi, then you have the urban heat island effects, which are affecting their incomes and their
Totally,
health.
totally. You put it right, Chetan. In fact, the migration is happening within states also. For example, in Maharashtra, people are leaving agriculture and they are moving on to the urban setup. But we see in the coastal also, coastal farming, I mean, whether it's fisheries or whatever indigenous work occupations that they have been engaged with, they are shifting from that also. So they are taking up other jobs in much more worse conditions. So it can be the urban setup where, like you said, they are exposed to heat and they do not have any provisions for healthcare system. But also these people get exposed to new extremes that have emerged. For example, in this map itself, we see Arabian Sea has shown, much more rapid warming compared to any other regions. In fact, Indian Ocean warming has been much more rapid compared to the Pacific or Atlantic. So climatologically itself, Indian Ocean is the warmest, has the warmest waters because it's landlocked in the north with South Asia compared to the Pacific or Atlantic, which is open in the north. So the water in the equator or the tropics can get flushed out to the north and both north and south.
See,
Yeah. But the Indian Ocean, the waters, warm waters, doesn't get flushed out that easily. Even in the south, the currents do not flush out as fast as other regions. So if we get more heating in the Indian Ocean, it gets confined in that region for quite a long time. That flushing out rate is slow. So one region that where the temperatures have been warming is Arabian Sea and the Western Indian Ocean. And this changes the monsoon that we talked about. This changes the storms and the cyclones because both the monsoon and the cyclones derive their heat and moisture from the waters. So when there is more ocean warming, like Arabian Sea warming, it pumps out a lot of moisture. But what happens is because, like I said earlier, the monsoon winds are weakened. So it is not releasing, it's not get that moisture is not getting inland. It is pumped towards some regions where the winds are strong. And we see regions like Gujarat, Rajasthan receiving more rains than earlier because there is more moisture. And we see more extremes happening. So whenever there are, so it's not like the monsoon winds are weak throughout the season. There are episodes when the winds are strong or normal as earlier. And those times, when those episodes happen across 3, 4 days, it carries all that moisture, dumps in a short period of time, whether it's West Coast or Central India or Northeast India. So that is
that's when you see all those pictures of
extreme. Yeah.
urban flooding, cars
Yeah.
floating on our
Yeah.
roads, and
Exactly.
yeah. So
Yeah.
very quickly, one thing that I'd like to touch about before we just move on to the rest of the questions, and I have a whole
Yeah.
bunch of them, is the melting of the glaciers. How is this affected? Is it just because generally of global warming, or is it the same thing that affects the monsoon? It's affecting the glaciers also.
So definitely part of it is straightforward. It's that air temperature warming and changes in circulation and so on, resulting in retreating and melting. This affects downstream population also. Again, that migration and agriculture impact is happening. So there are some regions in the Himalayas, glacier melting is happening consistently. There are some other regions where, bit of accumulation actually has happened. But overall, there is more retreat than accumulation happening. And this is because the local atmospheric circulation changes, the differences and the uneven changes. So definitely this is connected to that increase in temperatures resulting in more melting of snow and also less snow and ice and less snowfall happening in some of those regions.
The issue of sea level, particularly on the western coast, have you identified which cities are most vulnerable? Because you've got so many major cities there, right? From Mumbai to
Yeah,
Tiruvantanapuram.
yeah. Maybe we can put that picture of where I try to explain how sea level affects. So we think of sea level rise. Let me explain a bit of the science also. We think of sea level rise happening because of polar ice melting, in either in the Arctic or Antarctic, and elevating or enhancing that sea water level, right? Glaciers are also melting, like Himalayan glaciers are melting and adding on to that volume of seawater. But for our region, there are other factors also. So I talked about that ocean heating, 4 kilometers of ocean warming, and the largest warming is in the Indian Ocean. And that also adds to the sea level because there is something called thermal expansion of water. When all that 4 kilometers of ocean is warming, it expands. So 50% of sea level rise, more than 50% of sea level rise in the Indian Ocean is due to that thermal expansion of water because of ocean warming. And we know that the warming is not uniform. I told some oceans are warming more. And within those oceans, also like in the Indian Ocean, some regions are much more warmer than others. So Arabian Sea, Bay of Bengal, we see a lot of warming. And Bay of Bengal, I would say the sea level rise is much higher than the west coast. So east coast of India, it's about sea level rise is around 5 centimeter per decade. And also, if you think about the amount of land intruded, that becomes so huge. So, if you think about sea level rise in a decade or a century, or the land intruded by the seawater, then that becomes huge. So, I will give an example. So, the west coast is the sea level rise. Current sea level rise is 3 centimeter per decade. So, in this picture, I show what a 3 centimeter per decade means actually. So if you consider average slope of the ground, which is closer to sea level, as around zero point 0.1 degree or something on an average, the amount of land intruded by the sea in just one decade, that's 10 years, is around 17 meters. So this basic geometry you can calculate with the slope and the amount of sea level rise. So 17 meters of land intruded by the sea in just 10 years is huge amount of land. So this happens more towards the regions where it is on par with the sea level. So on the west coast, we have rugged terrains. So some regions, like for example, in Kerala coast, Karnataka coast, and all, the Kerala, Kuttanad, Kollam, many districts are close to sea level, and we see them very often below water. Many of the paddy fields and all are below water. Now coming to Mumbai and all, Mumbai coast is much more rugged terrain. We don't see that very often. But uh, when it becomes more severe is when it overlaps, again, compound events. When a cyclone comes, for example, Arabian Sea cyclones have increased by 50% in the last 4 decades. So if it was like zero cyclones per year, now it is almost one every year. So this increase in cyclones has is kind of overlapping with sea level rise because cyclones result in huge waves, what we call storm surges, pushing water. It can be a few meters high, 3 to 5 meters high or more. And we have to think that this is all salt water also pushing that water onto the land. And with sea level rise increasing year by year, decade by decade, the amount of flooding along the coast is much more higher. And this severity is much more high along the East Coast, actually. So we thought that East Coast has like Odisha, West Bengal, Andhra, and all. We thought that they were resilient to cyclones because Bay of Bengal, we have been seeing 3 to 4 cyclones per year on an average for a long time. But we have not been seeing this compound risk. So if you look at last few cyclones like Cyclone Amphan, Cyclone Fani, and all, which hit the East Coast, we would see that the damage was much more higher than earlier times. And because of cyclone forecasting, improvement of monitoring, and all, we are able to evacuate people. So the deaths are low, but the property damage to farms, damage to infrastructure has been higher. So the economic and social loss is much more higher. And people coming back, they don't have houses and farms or infrastructure or cars or any property anymore because their cattle is lost. And this is because of this overlapping compound risk. Because in the East Coast is much more flatter compared to the West Coast. So there, when a cyclone comes, it is pushing that water, salt water, tens of kilometers. We saw, I think, with cyclone often, I think around 60 kilometers inland. So that is like damaging the agriculture for the next several years to decades because it's salt water. And you know what? With yeah,
And I think, yeah, and I think that's what you also meant when you wrote that on how the warning arrives in time, but yet it seems to be too late because our structures, our systems, our emergency responses are just not equipped for this kind of
exactly.
extreme kind of understanding.
Yeah,
If I may just move on to one other thing, and this is India focused. India's climate action now is quite complex. We have the moral high ground, which is lowest per capita emissions. Historically, we're not the major biggest polluter, and we urgently need energy to lift millions out of poverty. But the science is clear, we need to stop burning fossil fuels. And the thing is that India still has plans to build new coal fired
yeah.
power plants. Now, as a scientist navigating this complex reality, what is the ideal science backed climate pathway that you think India should follow over the next, say, 5 to 10 years? What is the balance between our developmental needs and the absolute necessity of rapid decarbonization?
Yeah, people might call it tricky, but I think it's crystal clear what is causing climate change, where are the sources, who all are part of it. So I don't want to mince my words. So if US, Europe, and all were historical emitters, India has joined the bandwagon already. And the latest report that came out recently shows that now India has scaled up its coal production. India exceeded 1 billion tons of coal production in 2024. And not only that, India is producing that much, and India is also importing coal, around close to somewhere between 200 to 300 million tons of coal is being imported. This shows that our energy demand is going on an exponential curve. And many times, like in the last few years, I have seen those months where the energy demand is so high that on urgent emergency basis, India is importing coal in some of these months. So I don't see uh, the curve going down immediately. And we see similar uh, response from major emitters like the US and so on. So this is a serious issue that unfortunately we haven't tackled. And if you look into the philosophy and all, the humans have been on that energy intense curve for a long time, and we are going to continue that curve for an indefinite period as of now. Because despite the COPs and IPCC reports that scientists turn out and all that, all the warnings, despite the fact that we know mitigation is the one and only transformative mitigation is the one and only way that we can seriously flatten the curve. We haven't taken that action, and India also has a huge responsibility because we are not the historical uh, polluter in terms of or emitter in terms of carbon dioxide so far. But down the lane, in the next 2 decades, we will be the historical emitter. Will we take that moral responsibility of what we are doing now? Because at this is a time when we have better technology, better information, better data on how we can flatten that curve. Of course, we have 1.4 billion population. We need that development to sustain, but we need a better framework, better better plan in terms of being more sustainable. There's a much more clear sustainable pathway several research has shown up. So that's a path that India has to take in terms of mitigation. And we need to focus on adaptation urgently. This is where India is lacking, and because the framework for mitigation can be placed on a national level. But when we talk about adaptation, it has to work at panchayat level, at very local level, panchayat to district to state uh, to national level. We need climate change adaptation plan at panchayat level. We need to safeguard for all the extremes because even though climate change is global, the manifestation of these impacts are very local because you saw that what is happening in Mumbai is different from what is happening in the East Coast. What is happening in Bangalore is totally different from what is happening in Delhi. Similar for rural areas as well. What is happening across Kerala, even within a state, will be totally different. In Maharashtra, some states are more drought prone and drought and water scarcity is increasing there. Some districts in Maharashtra are more prone to landslides and flash floods. So in some areas to cyclones and all these coastal flooding and inundation due to sea level rise. So we need localized adaptation happening parallelly and at an urgent level. And it's not easy. We need several ministries, several departments, both public and private sector communities, all to work together for that to happen.
And speaking of decarbonization, I think it would be important also to talk about India's air pollution
Mm.
crisis, which is a massive public health emergency, not just in Delhi, but I think in many parts of the country. And it is also closely linked to climate. I think the IPCC has said that it's climate change and air pollution are two sides of the same coin. As a climate scientist, what is your take on India's air pollution crisis, especially from a climate lens?
Yeah, like you said, if we work on both mitigation and adaptation pathways, actually help reduce pollution in a large way because we are when we work on especially on mitigation and adaptation, we are sustainable adaptation, we are working on the sources, much more greener sources, renewable energy resources, but also fuel efficient pathways which will reduce the pollution, industrial pollution, vehicle based pollution, burning, crop burning based pollution. This can all reduce if we work on adaptation and mitigation pathways. So pollution in Delhi and other regions, surrounding regions, especially North India, requires strong political will, but also transparency. Transparency in terms of particularly data. We need to monitor the pollution clearly. Because without measuring, you cannot manage. That's an underlying philosophy that we cannot just show away, whether it is climate change or even pollution as well. If we get monitored well, we can monitor the source also, we can track also. We have perfect monitoring systems to do that, to tell you how much of pollution is happening at the at a particular location and also at the source, how much of pollution is being created. But we can also track the pollution sources using both the monitoring systems, but also models. So we have all these ultra, uh, ultra equipped systems to monitor and track pollution. We know where the sources are. We can quantify the sources as well, so that we don't need to keep on arguing. Is it the vehicles causing pollution? So we go for or even cars in Delhi? Or is it the crow burning? Or is it Diwali burning, crackers burning? Or is it, industries around? Or is it somebody like one of my colleagues said, is it the tandoori's burning? So all this is, biomass burning and all this is happening across the North India, which is cumulatively resulting in huge amount of pollution. And on top of that, we know meteorologically, climate-wise, basic climate-wise, geographically, the northern parts, including Delhi, is in that area which is surrounded by hills, and it is where the air doesn't move. That stands still for several days if the winds do not work out. So pollution accumulating stays there. So it can be local pollution. Local pollution can account up to 30 to 50% or more, depending on the day and how the meteorology is. It can be pollution from outside that again can account up to 70% or more. So we need the states to work trans-border. We need transparency on how much the sources are generating this pollution, and we need policies in place and to be implemented. This, I mean, the pathway, the science is clear. The how the pollution is happening is clear. We need the politicians, the policymakers to work on that and implement so that we don't have to breathe poison. The air we breathe should be, we have that right. So, like I said, this should be a national security issue, public safety issue. It should not be just an environment, shoved away saying that, okay, it's an environmental issue.
Exactly. Quite really agree with you. So, towards the end now, you have just returned from a major IPCC meeting in Paris, which came at the end of this bleak year that we've spoken about of missed targets and rising emissions and political will, which is sort of dwindling. So, I'm curious about the mood in that room full of the world's topmost climate scientists. In these official meetings or even informal conversations, what was the dominant sense that you got from fellow scientists? Was it frustration, anger, feeling of resignation, or was there some optimism?
Well, there I want to respond that we try not to be emotional about it because that will not help. So scientists, especially the IPCC scientists, we have clear, you know, methods for working, and we do not put our emotional tag, country tag, and all that. We work totally based on evidence based on data, and to some extent, evidence based on the models, based on the physics and the science of it. So in the IPCC meeting, like the last meeting in Paris, the first lead author meeting for the next IPCC cycle. And this is almost a 3-year cycle from scoping to, when the reports are out. So the reports will be out by mid 2028 only. So you can see the last IPCC report was in 2021. And all of us are aware of the numbers that we are facing as a globe in their own countries. People from more than 100 countries came there. There were around 600 plus scientists there. And all of us are facing these issues. But what we understood is that most of the governments are also not on binding agreements in terms of reducing it. So, and also not only that, these governments, for example, from the US, there has been many oppositions, and they are not supporting, for example, NOAA scientists in taking part in climate related research, climate related monitoring, climate related meetings, IPCC reports. So we saw a clear lack of scientists from NOAA. NOAA is the National Ocean Atmospheric Administration, the key organization in the US that has a global presence in terms of monitoring climate, but also understanding the long-term changes in climate. So uh, we saw a lack of these scientists, not just in IPCC, but all kind of climate discussion, which is impeding or challenging our work on climate change. Yeah. But otherwise, we keep taking stock of what is changing at a global level, at a regional level. It may seem that we are doing the same thing again and again, churning out report after report, and the curve is going up. But we come with much more clearer numbers so that we know exactly, precisely how much we need to reduce emissions, how much we need to adapt where and how, what is going to change in the future so that we can prepare our infrastructure, our farms, our houses based on the future changes. Because if you build a highway, or if you build a house, or if you build an institution, a hospital, a school, we are hoping that that will last for the next 20, 30, or 50 years, right? But very often we build that based on past data, past floodlines, past cyclones, past heat waves. So when extreme heat happens in the near future, like in the next year, next 5 years, next 10 years, we are unable to survive that. People die, or health issues come, or our house is broken or flooded because of these extremes of the future, which we are experiencing now. For now, because our current houses, our current infrastructure is not withstanding or surviving the challenges that we didn't try to foresee in the past. So we are checking out these numbers, assessing how the climate is changing in the future, and also bringing out emerging trends like the marine heat waves that we talked about.
And by 2028, I think there's one report which came out that the world would exhaust the carbon budget to try and stick
Yeah.
within the 1.5 limit by 2028. So yeah,
1.5
it's
is
going to be a
already gone.
pivotal year.
Yeah.
It,
Yeah.
it's already
If
gone.
somebody is
Yeah,
saying that
yeah,
we can
that's
still stick to, or, even somebody saying 2028, I will say they're just being polite. They're just being soft.
yes. Well, Roxy, thanks very much for this conversation, for being so rooted in the science and explaining it simply. If this conversation helped you make sense of a lost year for climate and what needs to change next year, do share it with someone who follows climate news and leave your question for Roxy and me in the comments, and we'll try and get back to you. I'm Chetan Bhattacharji, a longtime journalist now focusing on the science and solutions around climate change and air pollution. Thanks for watching our Chakra. And Roxy, thanks very much for making time
Lord
once again.
Chetan, that was a wonderful discussion, and I hope people come forward and make sure that that political will is there for saving that 1.4 billion population.